Back everyone to the Hello World Guide. This is another episode of the Mario in SFML series, and in this video we are going to finally implement the animations. So first of all, let me show you the animation sprites that we have got. We have got like 3 sprites for the run animation, which let me show you. I turn off the grid. You can see this is one sprite, this is another sprite, and this is another sprite. These are 3 sprites that the Mario run animation is going to be based off. And by the way, just remember that I have actually changed this. The new sprites have got a size of like 16 by 32, which means that I have changed Mario's actual in-game size accordingly. It's now 40 by 80, and we'll discuss everything else later. So for the animations, let me just first show you 2 more pictures which I have not added to my project yet. You can do that by taking this so that you can open it in Visual Studio as well. These are idle.png and jump.png. Now for this Mario that we have basically got only one sprite for idle and jump. Like this is idle and this is jump, and that's how the original Mario worked. It did not like have a proper idle animation, so the only animation we need to implement is for the run sprite, and the rest of the sprites are only going to be like one sprite, things that we can switch based on our like state. So first of all, let me go ahead and show you let's start off by main.cpp. In here, of course, if you remember, when we were implementing the game loop, we used a game clock here to do a bunch of stuff with this. So in here, but make sure that when you do game clock dot restart, it's being called only at the start of the frame, and we don't need to say like get elapsed time separately. We can actually store the time we have got in an sf colon time. You of course don't need to actually do that. You can just use clock dot get elapsed time or something, but we do it like this, and we update Mario with the delta time, which is essentially going to be we are taking the sf colon time and we are converting it into seconds. Now what is this doing? So if we look, this is the game's clock, and when the window start like when our game loop starts, we essentially just at the start of every frame we reset the clock. So the clock's value, whatever it was, is reset to 0, and the amount of time that the clock has passed is stored in this. And then what we do later is that when we are updating anything, we pass it the delta time as seconds, which means, because you can also pass it as microseconds or milliseconds, but we pass it as seconds. And then this whole thing runs. Then we go to the top of the while loop and start again, where we again reset the clock and get the elapsed time. Now what is this doing? What is this essentially is doing is that this essentially records the amount of time that has passed in this frame. So how much time it took to like execute all of these statements, take all of the events, then update Mario, then set the view correctly, then go ahead and clear the window, then draw everything, and then display the window. But how many time it took to actually execute all that, and that is essentially what this delta time is. And we are essentially using this to like multiply it with Mario's speed to actually get Mario's speed and jumping velocity and everything to be frame rate independent. So even if someone is like running it on like a 10-year-old computer, it might be a bit slow. The game will be slow, but Mario will still move as fast. The game will update less often. And if someone is running on a really fast computer, the frame rate might like go to 400 or something, but Mario will still take the same amount of time to go from one end of the map to the other. So this is essentially what we are doing. And since the frame rate is non-fixed, we are multiplying with the delta time. It works with animation. We cannot actually put the animation as frames, because if we do that, then the animation speed will depend on the frame rate, which may vary, which will cause a lot of problems. So when we are updating Mario, what we do is that I have actually created a separate class called animation, and let me open up the animation class. In here I have got a structure. We are using a structure because everything needs to be public here, so we just use a structure in the animation class. Before the actual animation class, we have got a structure called frame. Now what is this frame? So if I go here, as you should know, animations is basically made of different kind of frames, and each frame has got a texture, which is actually a pointer to the texture, because remember, we need to store the texture's address, because if a texture is destroyed, SFML does not keep a copy of the texture. The sprite only keeps a reference to the texture. So we need to store here as pointers, and we have also got a constructor here setting everything, and we have got a float called time. Now this time essentially represents the time where this frame is supposed to end. Not the time where it's supposed to start. It's the time when it's supposed to end. So if I go under animation, we have got a bunch of private variables. We have got a vector of frames called frames, of course, because animation can have any number of frames. We can like have from anywhere from 2 frames to like 100 frames or something. We can add as many frames as we want. And then we have got a float called length and another float called time, which okay this time variable essentially represents the amount of time that this animation has spent. So we will understand its implementation a second later. And this length is of course the actual, how much time this animation takes. And if I go under the functions, we have got of course an animation constructor, and we have got a void for adding frames to the animation, because of course we don't have a visual editor. We will have to do everything in code. And we have got a update function, which of course takes delta time like every other update function in this game, but it is not void. Instead it returns a pointer to a texture. This texture is a texture that is actually supposed to be running in the animation. So if I open up the implementation by going under animation.cpp, you can see that for the constructor we just set the length and time. So the length is set to whatever length we got passed, and the time is set to 0, because of course the time is supposed to be 0 at the start. And in the add frame method we just do frames.push_back frame. Now in here, in the update method, what we do is the time of the animation, we add the delta time to it. This will essentially allow us to measure the actual amount of time that is passed correctly. So this delta time is the amount of time a frame is taking, and actually this is the amount of time that the last frame took. And this update method is being called every frame, though. So we are essentially adding the time to delta time to time, which is allowing us to record the time that is passed after the animation. So we run a while loop here, and the reason we do that is because we want the time to never exceed the length. So if the time is ever greater than or equal to length, we subtract the length from the time until we get to 0. The reason we do that this in a while loop instead of a if statement or something is because, for example, if the time is 2.2 seconds and the animation's length was only 1 second, this is highly unlikely, but if the frame rate is extremely slow, it might happen. So if the time is 2.2 and the length is 1, we first subtract 1 from 2.2, which becomes 1.2, then we subtract 1 again, which becomes 0.2, and now it is less. So that actually allows us to get the actual correct frame that's supposed to be rendering at this instant. So that's the setup out of the way, and here is the actual good function. And in the end, if nothing works, we return null pointer. But what we do here is that we loop over the frame, so we get each frame, and if the time is less than the frames and time, so the current time of the animation is less than the frames time, so the frames time limit, then we return the frames texture. This essentially what this does is that it returns the correct texture that the animation is supposed to currently have, so that we can change the sprite according to this texture. So now with this out of the way, this is basically all of the implementation of the animation class. Now let's go under Mario.h. In Mario.h we have now we have a animation. First of all, a separate animation called run animation, because remember the idle and jump for this implementation for the sprites I am using are just one sprite, which means we don't need animation for that. We only need the run animation. We have got an animation here called run animation, and we have got a texture here, texture array here of 5 textures called textures. And the reason we have an array is because we could use a vector, but since the amount of textures that Mario is using is always going to stay the same, it's much more efficient to use an array. We are using a C based array here, which means that we need to make sure that we get the correct amount of everything. And even though it might be better to use a C++ array, and you can do that of course as well. But yeah, this also works, but we need to make sure that we do not access anything outside of the size. So if I go under Mario.cpp, we have got these 5 textures, and in the init method, one thing you will notice is that in this init method we don't really set the sprites texture. Instead, what we do is that we load each of the textures. So texture 0 we load from file, we run the same method on all of these, but we load run 1 here. So the first texture index is actually run1.png, then we load run2, run3, idle and jump. So we load each of the files that we are supposed to, and then we set up the run animation. We go and say run animation dot add frame, and we create a new frame here. You call it by calling the constructor, and we pass it the address of the textures, and this is important, and then we pass it the ending time. So the animation, if you go in here in the constructor, I have set the animation's length to be 0.45 seconds. So when we are running this, when we are adding the frame, we add a texture 0 here, and then we add 0.15 is the end time. So each of the frame is like divided equally, and the next is like 0.3, and the final one's end time is the end time of the animation, which is 0.45. And we add these three textures to this animation, and these are not added to any animation because these are just one textures. And now if we go down here in the end of the update function, what we do is we check if we are not grounded. If we are not grounded, then we set the sprite's texture to textures 4. The reason we set it to 4, of course, is because this 4 is the jump .png, which means we set it to the last texture what we have got. And if that is not the case, which means we are on the ground, then what we want to do is we want to check if the player is moving. If so, we want to display the move animation, else we want to just display the idle sprite. So for this, we check if we first use the apps function for get the absolute value of velocity, because whether it's positive or negative, we still want to display the animation. We check if it is greater than 0.02, and we do 0.02 to kind of prevent any errors here. You can use 0 if you want to, but 0.02 is better. So we do that, and then in the sprite.set texture, we do not pass it a texture from our textures, but instead what we do is we go and say run animation.update. We run the run animation.update method with the delta time, of course, and we get a texture pointer, and we use this pointer like this symbol to actually dereference the pointer, which means instead of the address, now we get the value of the texture, and we set the sprite texture to that. And if Mario is not moving, we just set it to texture 3, which is the idle animation. Now what you should see is that everything works perfectly, and we have got a working and animated Mario. So yeah, you can see that everything is working, and now Mario can like run, and everything is quite nice. Now this is pretty much it for this video, and we have basically done everything for our basic Mario game. Of course, there's a lot to add, and with this knowledge you should be able to like add more features like pipes and Goombas and ending level, menu screens, and everything that a complete game needs. So you should be able to do that on your own now. So there is one thing right now that we have not implemented in this, which we are going to do. Actually there are two things. So the first one, which is the next video is going to be about, is that if we resize the window, you can see that the screen's aspect ratio is not correct right now, and everything looks kind of squished together. And if I maximize it, you can see everything is now stretched. That's because we are not our screen size is always remaining same regardless of what it's supposed to be. So we need to fix these problems along with a couple of other things. So we'll not end the series just yet. There will be a couple of more videos, so stay tuned for them, and make sure to like and subscribe as well, and share this video with other people, and bye.